Okay, so I would like to take a little bit of time to go over the worksheet from last night. Um, the homework assignment was to complete Unit 7 Worksheet 3, Neutral Lewis Structures. Basically, we're drawing the structures that we worked on in class. So to take a minute or so and go over the answers here, I'm just going to go through the process just like we did in class yesterday. So the very, very first one, it says that our formula that we're working with is ASH3. And as a result of that, we need to first of all figure out what our electron bank is. So it looks like I have one AS, and I'm going to do it kind of in the middle because I have more room here. So I've got arsenic and I've got hydrogen. Looks like I have one arsenic, and according to the periodic table, arsenic is in the arsenic is in the 15th column. And if it's in the 15th column, that means that it is going to have 5 valence electrons. So I know that it has 5 valence electrons. So I'm going to multiply that times 1, and I'm going to get 5 valence electrons for arsenic. I have 3 hydrogen times 1 valence electron. So that gives me 3 hydrogen or valence electrons total for hydrogen. I'm going to add them all up, and I'm going to get 8 total valence electrons. So those are all the valence electrons that I have to work with in terms of making this work. So the next step is to take our atom, or figure out what our central atom is. And in this instance, our central atom is going to be arsenic for one of 2 reasons. One, either one, it's because it was the first atom in the compound or the chemical formula, or 2, it's because it was the only element, or is the element in the compound that there's only one of them. So I'm going to start with arsenic and put arsenic in the middle. And around arsenic, I'm going to put hydrogens. And I'm going to put hydrogens around like so. And then I'm going to draw a single line to show that they are bonded. Now remember that a line is equal to 2 used electrons. So if I have 3 lines that I used in this case, it would be I used a total of 2, 4, 6 electrons. So minus 6 gives me 2 valence electrons that I still need to find a home for. So before I just start randomly putting valence electrons down, I'm going to first of all remember that hydrogen is one of the exceptions to the octet rule, and hydrogen is an element that only needs 2 electrons to have its most stable arrangement. So if hydrogen on the left-hand side has one line, that line would indicate 2 electrons are present. So that hydrogen has 2 electrons and it's satisfied. The hydrogen on the bottom, 1 bond, 1 line, 2 electrons, has the most stable arrangement of electrons. Hydrogen on the left, 1 line, 2 electrons, most stable arrangement of that particular atom as well. Now, so all of my hydrogens are in their most stable arrangement, but arsenic at this point has 3 lines around it, and each line is 2 electrons, so 2, 4, 6 electrons have been used or are around arsenic. And since I have 2 electrons left, I'm going to put those right here on the middle. So now my arsenic has 8 total electrons. It has 3 lines for 2 electrons each, 2, 4, 6, and then 2 electrons as dots. So that gives it its 8 valence electrons. So here we have our compound, and the compound is drawn correctly. The next thing that we have to do is figure out the bonds and the bond types. So in this case, I have arsenic and hydrogen. And when I go to figure out the electronegativity difference, I need to consult the periodic table. So on the periodic table that I have in front of me here, I see that arsenic has an electronegativity of 2.0. And I see that hydrogen has an electronegativity of 2.1. So with that in mind, I can now go back and fill in my arsenic, which was 2.0, and hydrogen, which is 2.1. And when I subtract the two of them, I get an electronegativity value of 0.1. So that 0.1 tells me that I have a non-polar covalent bond. So each of the bonds, the arsenic and hydrogen bonds, are nonpolar, and they're nonpolar covalent. So I don't need to draw the arrows, the dipole arrows, and I don't need to draw the partial charges. The last thing we're supposed to do here is name the molecule. When we name the molecule, we're looking at ASH and writing the covalent naming system that we learned the other day. So I go to the periodic table and I see that I have arsenic, which is the name of the first element, and I don't need, the first element, I don't need a prefix on that because there's only one of them. And then I have hydrogen, D-R-O-G, and I'm going to drop I'm actually going to drop this is kind of a weird one. I'm going to drop the RO, so it's going to be hydride in this instance. And there's 3 hydrogens, so we need to tell the world there's 3 hydrogens. So I'm going to put the prefix tri in front because that means 3. So the correct name of this compound is arsenic trihydride. So if you have any questions about that, let me know. All right, now we're going to move on to the next one. In the next one, which now looks different than the one that you guys were working off of. Holy buckets, let me check. All right, sorry about that. For some reason, I thought that the Lewis structure for the second one was different than CS2. So I'm not really sure where my head was at there, but all right, so let's talk about that. So we have CS2, and there's a 2 there, but there's only one C. So let's start by filling up our electron pot. So carbon in this particular instance is, there's 1 carbon. And according to the periodic table, carbon has 4 valence electrons. So it brings 4 valence electrons and throws them in the pot. And then we have sulfur, which there happens to be 2 of them. And each sulfur has 6 valence electrons. So all of the sulfurs bring 12 valence electrons to the total pot. And 12 and 4 is 16 valence electrons. So we're going to start by placing our central atom. And one of the 3 ways that we can figure out whether the central atom is that if it's the first element, check. If it's the first element and there's only one of them, check. And then the other one that came up the other day or yesterday in class was that if it happens to be carbon, chances are it's the central element. So in this case, carbon definitely is our central element. And I'm going to start by then placing my sulfurs on either side. So now that I've placed my sulfurs on either side, and there's only 2 of them, now I'm going to go and start bonding them together with a single bond. So I'm going to draw a line here. I'm going to draw a line here. Now I've drawn 2 total lines. So each line is 2 electrons. So that's 4 electrons used. So now I'm left with 12 valence electrons. So now I'm going to start placing valence electrons. And again, it doesn't matter where you place them or where you start, as long as you just kind of try to use them all up. So I'm going to put them in pairs. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And oh boy, it looks like what we have here is we have the sulfur on the right-hand side has 1 line, which is 2 electrons, and 6 dots. So that's a total of 8 electrons. So that sulfur is in its most stable arrangement of electrons. The carbon in the middle has 2 lines with 2 dots each, or with 2 for 2 electrons each. That's 4 electrons plus the 2 dots, which is 6. So that one doesn't have its most stable arrangement. And then the sulfur on the other side has 1 line, which is 2 electrons, and 4 dots, which adds up to 6 again. So that's also not the most stable arrangement. So here's an example where we're going to make a multiple bond, but we're going to actually make two multiple bonds. So I'm going to grab the 2 electrons from this sulfur here and put them here and make a bond. And I'm also going to grab these 2 electrons from carbon here and make a bond. And now I'm going to redraw the structure to kind of clean things up a little bit. So I'm going to place my carbon in the middle. I'm going to place my sulfurs on either side. I'm going to draw my initial bonds, and then I'm going to draw the double bonds, the secondary bonds that I've added. And then I'm going to go back and fill in electrons. And if you look at the central atom, carbon has 4 lines attached to it. And if it's got 4 lines attached to it and each line is worth 2 electrons, it's a grand total of 2, 4, 6, 8 electrons, which means that carbon in the middle has all the electrons it needs. Both sulfurs have 2 lines for 2, 4 electrons. So both sulfurs are short 2 electrons. So now I'm going to go ahead and add 1, 2, 3, 4, 5, 6, 7, 8. So to go back and count how many electrons were actually used is I have 4 sets of 2 dots, so that's 8, and 4 lines, so that's another 8. So I've used all of my original 16. And I created 2 double bonds. So that's the most correct structure here. Now the next thing that we have to do is we're going to go ahead and check to see if what type of covalent bond is present here. And I'm going to be looking at the electronegativity difference between carbon and sulfur. So when I go to my periodic table, I'm going to see that carbon has an electronegativity of 2.5. Sulfur also has an electronegativity of 2.5. So if I plug that into the little bit of math that we have to do here, 2.5 minus 2.5 gives me 0.0. So we have another non-polar covalent bond. Now, to name this compound, I have 1 carbon. So I'm just going to write carbon's name. So carbon. And I have 2 sulfurs. So I'm going to write sulfur, but I'm going to drop the UR and add IDE. And then I have to tell the world how many sulfurs there are. So I'm going to put a prefix of di in front. So this is carbon disulfide. Hopefully that's not too bad. We have 1 more to go on last night's homework, which was SiH4. So the first thing we're going to do, just like we did the last couple of times, is we're going to identify the number of valence electrons we have. So we have Si, and there's 1 of them. And silicon, according to the periodic table, has 4 valence electrons. So there's 4 valence electrons from silicon. We have hydrogen. There happens to be 4 of them. A hydrogen has 1 valence electron. So 4 times 1 is 4 valence electrons. So we're going to add them up, and we have a total of 8 valence electrons that we have to place. So going ahead and determining what the central atom is. Central atom is usually the first element in the compound. It's usually the element that there's only 1 of. And so in this case, that happens to be silicon. So I'm going to place that right in the middle. I'm now going to go ahead and bond the rest of my elements to it. So I have 4 hydrogens. So I'm going to bond them by drawing a line. 1, 2, 3, 4 lines. Each line is worth 2 electrons. So I used 4 lines. So I've used 8 total electrons. So I'm down to 0 valence electrons left to use, which is what we want. Silicon then has 8 electrons around it because it has 2 from the first line, 2 from the second line, 2 from the third line, and 2 from the fourth line. So silicon has all 8 electrons, and hydrogen is that special element that only needs to have 2 valence electrons, and each hydrogen has 1 line, so 1 bond. So each little hydrogen is sharing 2 electrons. So the last thing we need to do is we need to analyze the bond for polarity. So here I see that I have silicon. So I have silicon and hydrogen. And when I go to the periodic table, I see that silicon has an electronegativity of 1.8 and hydrogen is 2.1. So I'm going to fill that in. So silicon is 1.8. Hydrogen is 2.1. 2.1 minus 1.8 is, what is that, 0.3? So I believe that's 0.3. 2.1, yeah, it's 0.3. I did that right. Which tells me I have another non-polar covalent bond. So the last thing we need to do is we need to name this compound. And there is 1 silicon. So I'm just going to write silicon. And then I'm going to write hydrogen again. But I'm not going to write all of hydrogen. So it's going to be like a hydra, get rid of the OEN, and I'm going to add IDE. And there's 4 of them. So we need the prefix tetrahydride. So we have silicon tetrahydride. And that was your homework for last night. Check your answers. Make sure that you correct any mistakes that you made. And we'll answer any questions on Monday. Have a good weekend.